Hey everybody, I'm going to go through hopefully a relatively brief rundown of your 3.2 material. This just has a couple of very important concepts with respect to enthalpy and reactions. I think looking at the enthalpy of a specific molecule and ultimately looking at a reaction diagram. So I'll go through that. And I'm sorry, I have a typo, not head of atom combination. That should be heat of atom combination. Okay, so whenever you see heat of atom combination, you'll generally see delta H, A, C. And you'll then see a compound that follows, for instance, N2. And that compound will have a state associated with it. We've got G, gas. And this has a value of negative 945.41 kilojoules per mole. Now, what does this mean? This all means that if you start with 1 mole of N gas, and you add that to 1 mole N gas, you will get N2, or 1 mole of N2 gas, and there will be a heat associated with that. Since you are making bonds, you are going from N plus N, and you are going to produce N2. What you need to know is, what does that actually look like? Well, N2 is a molecule that has 1, 2, 3, a triple bond between it, and each nitrogen atom has a lone pair of electrons. Okay, so that Lewis structure checks out. If you want to go through the process of doing that, go for it. Now, what this means is that 945.41 kilojoules of energy was released when 1 mole of N2 was produced, was made from 1 mole N and another mole of N. Okay. Now, what does that mean? Well, the exact opposite of that is also true. So if you go from N2 to N plus N, you're going to have a delta H for that, which is 945, I can't write, 945.41 kilojoules per mole. So you're going to have to input that energy to break that N2 up into N plus N. Okay, so the important thing is the sign of that. So negative delta H is associated, negative delta H is associated with making bonds, and positive delta H is associated with breaking bonds. Okay, so this is important to consider whenever we're talking about an overall reaction, which is what we'll look at on our next, next. Okay, so this next slide, what I want to do is I want to actually talk about a specific reaction. Let's say that we have O2 plus N2, and we're going to make N2O4. Okay, when you see that reaction, what you are being asked for is the delta HRXN. So you're being asked about, from these two components, from O2 and N2, is energy going to be released as a net, or is energy going to be gained as a net? Okay, so the first thing that you have to do whenever you do this is you have to balance this chemical reaction. Well, we've got 2 nitrogens on the reactant side, we've got 2 oxygens on the reactant side, so we put a 2 coefficient in front of there. Now we've got 4 oxygens. Okay, we're balanced. But what are we doing here? This is the question that is very important to ask yourself. We are taking O2, and specifically we're taking 2O2, and we're breaking it down into, well, O plus O. But we're doing that 2 times. Okay, N2. We're taking that and we're breaking it into N plus N. And all of these are moles, so we're taking 2 moles of O2 and breaking it into 2 moles of O plus O, and 1 mole of N2 is being broken down into 1 mole of N and 1 mole of N, and ultimately we're going to produce 1 mole of N2O4. Okay, so now what you need to ask yourself is, what does it take to get from O2 to O2 to, well, 2 times O plus O. You also need to ask yourself about your other reactant, N2. N plus N. Okay, so you need to ask yourself, what am I doing here? In this phase right here, what I'm doing is I'm breaking bonds. I'm breaking the double bond that exists between O2, and I'm breaking the triple bond that exists between N2. With O2, I'm doing that 2 times over. So when I'm taking O2 gas, I'm breaking that down. Sorry, I didn't put the state there. What I'm doing is I'm doing 2 times 498.34. So I'm putting that energy in to break that molecule up. Okay, now with N2, I'm going to be adding 945.41. So I can use my calculator to figure out my total there. So how much energy am I actually putting in? And the energy that I'm putting in is 2 times 498.34 plus 945.41. Okay, so I'm inputting 1942.09. Now what I'm going to do after that is I'm going to take these components and I'm going to make 1 mole of N2O4. So the delta HAC for N2O4, that is going to be negative because I'm making bonds here. So what is my negative there? That's negative 1932.93. Okay, so what is my total, my delta H of this? Well, I input 1942.09 and then I got out 1932.93. So in this case, I'm just going to add my reactant, or my products, which is negative 1932.93. So 1942.09 plus negative 1932.93. My delta H of my reaction here is merely 9.16 kilojoules per mole. All right, well, I hope that was helpful, and I hope that that was a good review of, a sufficient review of atom combination. Remember the reaction going in the forward direction, or when you're breaking bonds, what you're doing is you're inputting energy. Whenever you're making bonds, you're releasing energy, which is why there's that delta, or that negative delta H for making bonds and a positive for breaking bonds. At any rate, there you go.